Metal becomes motion. Every surface shows precision. Steel and aluminum face extreme heat. For skilled workers on this line, the rhythm is exact. A modern engine needs hundreds of parts, working inside one compact unit. From these metal components, workers build a CVT transmission. It begins with the housing. First, clean the metal, then control the heat. Molten aluminum enters the furnace with scrap from earlier cuts. Reusing scrap reduces waste, but the alloy must be refined before casting begins. To move the liquid metal, workers use a shielded carrier. Heat-resistant glass protects the front, shielding the operator and limiting oxidation. Molten aluminum must stay in range. The temperature is monitored, usually around 700 to 760 Celsius. Too cool and it will not flow. Too hot and the alloy can weaken. That is why robots handle the pour. They keep workers away from heat and improve die casting consistency. The mold gives the housing its shape. Its cavities guide the metal, forming channels and mounting points. Once the casting hardens, the robotic arm moves in. It grips the part and sends it to CNC machining. When the line runs well, automation keeps output high, even through long shifts. Machining has two steps. First, extra metal is removed. Then the surface is cut again for a cleaner finish. Now, the housing is close to its final shape. If a rough edge remains, it goes to grinding and finishing. This can take only seconds. That speed matters, because the next station is waiting. There is no time to waste. Next comes another key part. A gear blank. At first, it is just a steel blank. The blank is cut, then heated above 1000 Celsius. Into the press, this is the forming station. Below are 3 separate dies, with each press stroke. Hot steel changes shape, but pressing is not final machining. The press forms the body, but not every detail. After the blank leaves the track, another die waits ahead. This adjusts the thickness, plus the diameter and length. The recessed sides are critical. Without them, the part will not fit. Only minutes later, the steel is pushed out. From inside the die, the surface glows red, showing the heat still inside. Now comes heat treatment. It relieves internal stress and stabilizes the part. After housings and gears, one question remains. What carries the load? And how is it made? Planetary gears are forged too. The equipment is larger, and robots move the work faster. Compared with older methods, this is more efficient, but this heat station throws off serious heat. It is hotter than nearby areas, even several meters away. You can feel it. The gears are inspected. Workers sit along the conveyor, checking each part. Only approved parts continue. Teeth are cut. The blank becomes a working gear. After another heat treatment, the gear becomes stronger. Now the parts are nearly ready for final assembly. Each part must pass inspection before assembly. Visual checks are only the start. The gear is measured by a precision measuring machine. Its profile is checked closely. In a transmission, almost right is not enough. That is why inspected parts go to dedicated stations. Fresh furnace parts do not go straight in. They are measured and checked one by one. It may look slow, but this is where quality begins. A smooth transmission depends on it. Some parts are measured by several instruments at once. That is what we see here. Are gears the only parts in a CVT? No, not at all. There is also the steel belt. Before assembly, it is checked. The part is placed down, secured, and connected above. The system checks its movement. Only seconds. Once the target is reached, the part moves to assembly. This line is human-assisted. Each worker handles one task with only a few movements. That lowers fatigue and mistakes. The holes are aligned, but tightening is not done by hand. Human force is never identical. A torque tool handles it. Each fastener is tightened after the first bolts are secured. The worker installs a wired component, then sets it in place. This is where a CVT is different. It is not a regular gearbox. The key part is the steel belt. It uses many steel elements and layered steel rings. Together they form a flexible loop. A normal gearbox does not use it. Power is transferred differently. At the same time, the aluminum cover is positioned by hand. Sealant is already applied. It helps prevent oil leaks. Inside is a small chain mechanism. It looks almost like a bike chain. For speed and accuracy, a robot installs the bearing. Safety glass around the station keeps hands away from moving parts. The flat center surface has already been drilled. Sealant flows from the needle, following the exact sealing path. Once both parts are sealed, they move forward automatically. No wasted motion, no delay. The process looks controlled. But tiny misalignment can stop the bolts from seating. When the upper robot releases, another fixture takes over. It holds the part steady, so bolts can tighten in one pass. Some viewers may wonder, does every unit need inspection? Yes, every single one. First, the left fixture locks it. Then the right side tester starts its cycle. Any problem, from surface damage to odd movement, can be caught before it leaves. CVT means continuously variable transmission. It has no fixed gear steps. It works differently from manuals and dual clutch units. Those use fixed steps, like 6-speed or 8-speed layouts. A CVT is smoother. It changes ratio continuously, so acceleration feels steady. A manual or dual clutch unit shifts in steps. Each shift moves to another gear. A CVT stays smooth.